big hello to all the wonderful children watching this video. So far we have completed lessons on circle, introduction to Euclidean geometry, which was a subject enrichment chapter, and then coordinate geometry. We move on to the 12th chapter of the NCERT textbook, that is Heron's Formula. Heron's Formula is based on area of a triangle. So in this chapter, you're going to learn how to apply Heron's formula in finding out the area of certain triangles. Please have a look. Area of a triangle by Heron's formula. Heron's formula is credited to Heron of Alexandria for finding the area of a triangle in terms of its three sides. The formula given by Heron about the area of a triangle is called as Heron's formula. So, when do you use Heron's formula? What are the type of triangles in which you can use only Heron's formula? You're going to learn that in the forthcoming. When to use Heron's formula? You are aware that area of a triangle is half into base into height. So if the base and the height is known to you, you can find out the area of the triangle. Similarly, area of a right angle triangle is half into product of the perpendicular sides. If the two perpendicular sides are known, you can find out the area of a triangle. But what about a triangle like this? Triangle ABC, in which the height is not mentioned. Only the three sides of the triangle are given, that is AB, BC and AC. So how do you calculate the area of this triangle? You cannot use the formula half into base into height because height is not mentioned. So in such case, you will be using Heron's formula. So when is Heron's formula used? Heron's formula is used to calculate the area of a triangle when the three sides of the triangle is given and the height is not known. Let us now calculate the area of a triangle using Heron's formula. I have drawn triangle ABC wherein the three sides of the triangle is given. Now you start off the solution by mentioning let small a equal to 40 centimeter, small b equal to 24 centimeter and small c equal to 32 centimeter. Ideally, what is a out here? Look at angle A. The side opposite to A is small a. So BC is actually small a, which is 40 centimeter. The side opposite to angle B, that is AC, is small b. So B is equal to 24 centimeter. And the side opposite to angle C is AB, which is 32 centimeter. So you have A, B and C. Then you find out the semi-perimeter of triangle ABC. Semi-perimeter means half the perimeter. And you know that perimeter is A plus B plus C. It is the sum of the three sides of the triangle. You add them, 40 plus 24 plus 32. Divide them by 2 and you get the semi-perimeter as 48 centimeter. Students, I want you to make a note of this. So semi-perimeter is 48 centimeter. In calculating the area by using Heron's formula, you need to find out the semi-perimeter of the triangle first. After having found the semi-perimeter of the triangle, use the formula. Area of triangle ABC. This is the Heron's formula wherein square root of S, S minus A, S minus B and S minus C represent area of triangle ABC. S stands for semi-perimeter and you're subtracting the three sides of the triangle from the semi-perimeter. So substitute the values. S you know is 48. S minus A is 48 minus 40 because A we have taken as 40. S minus B is 48 minus 24. So B here value is 24, and S minus C, that is semi-perimeter minus C, that is 48 minus 32. Okay. Then you calculate the difference. 48 and 48 minus 40 is 8. 48 minus 24 is 24, and 48 minus 32 is 16. What you have seen here is you have taken A, B and C as 40, 24, 32. That is the correct way of taking A, B and C. But if you take small a as 24, small b as 32 and C as 40, that is also correct. You can take any value out here. You could represent A as any one of these three. You could represent B as any one of these three, and same is the case with C. Values can be interchanged. Answer will not change. But ideally, it's always like this. Small a stands for the side opposite to measure angle A, and this is B and this is C. But you could also interchange the values. It is right. Now, do not multiply these numbers. You're going to find out their square root, so split it up. Either split it in terms of prime numbers, or 48 you can write as 2 into 24 because there is already one 24 out here. So 2 into 24, this 24 and this 24, you can find out the square root later. 8. 8 can be expressed as 2 into 4. 24 write it as it is, and 16 also you will write as it is because you can take out the square root of 16. Okay. Now next step. Square root of 2 into square root of 2. That is, what is root 2 into root 2? Root 2 into root 2 is 2. So 1 2 will come out. Then you have root 24 into root 24. So another 24 comes out. Then you have square root of 4. Square root of 4 is 2. And square root of 16 is 4. Multiply these four numbers. You will get the area of triangle ABC equal to 384 square centimeter. So in this question, we have found out the area of the triangle by using Heron's formula because they have not mentioned the height, so you cannot use half base into height. Since the three sides are given, we will use Heron's formula. And it is your choice. You can take any number as A, B and C from these three. Okay, let's look into another problem based on Heron's formula. The sides of a triangular plot are in the ratio 3:5:7 and its perimeter is 300 meter. You have to find its area. So a triangle is drawn out here. It is not mandatory to draw a triangle. You can even solve this without drawing a triangle. One of the side is 3x, other side is 5x, and the third side is 7x. When a ratio like this is given, you could start off by writing, let the common multiple be x. Therefore, the three sides are 3x, 5x, and 7x. Or you could also put it like this. Suppose that the sides in meters are 3x, 5x, and 7x. Now the perimeter is mentioned as 300 meters. So add the three sides and total it to 300 because it is the perimeter of the triangle. Perimeter is sum of all the three sides. When you add the three sides, you get it as 15x. 15x is equal to 300. So with that, you get the value of x as 20. So x is 20. So if x is 20, this side becomes 3 into 20, 5 into 20, and 7 into 20. So the sides are here, mentioned out here, 60, 100, and 140 meter. So calculate the three sides of the triangle. Now, once you have calculated the three sides of the triangle, you have to then find out the semi-perimeter. And semi-perimeter formula is A plus B plus C upon 2. You could mention A as the smaller value also 60, B can be taken as 100, C can be taken as 140. Or directly you can write semi-perimeter is equal to P upon 2, that is perimeter upon 2, that is 60 plus 100 plus 140 by, okay, and from that you get S equal to 150 meter. Now, area of the triangle using Heron's formula is mentioned out here. It is imperative that you write the formula given by Heron for finding the area of the triangle. Now, after mentioning the formula, S, we got S value as 150. Then it is 150 minus A. So A here is taken as the first value, 60. B is taken as 100 and C is taken as 140. Substitute the values. 150, 150 minus 60, 150 minus 100 and 150 minus 140. Square root of this 150 goes here. 150 minus 60 is 90. When you subtract this, you get 50 and subtract 150 and 140, you get the value as 10. Like I mentioned earlier, you will not multiply these numbers because if you multiply, calculating becomes slightly cumbersome. Split it. The clue is in this step itself. 150, split it as 50 into 3 because 50 is already there here. So 150 is written as 50 into 3. 90 and 10. You could keep it as it is or multiply them. 90 into 10 is 900 and 50 keep it as it is. Now take on to square root. Root 50 into root 50. That is square root of 50 into square root of 50 is 50 and square root of 900 is 30. So you have 50 into 30. Root 3 will come under the root sign itself. Okay, you can't take out the square root. So the final answer is 1500 root 3 meters square. 1500 root 3 meters square is the area of this triangle having sides 60, 100 and 140 meters. I hope you have understood this problem. Please make a note of this. Write down this solution in assignment sheet or in your notebook. Now, this is a problem based on exercise 12.1. Okay. Now, this is an equilateral triangle. Again, diagram is not compulsory. The three sides of the equilateral triangle I've taken as A because all the three sides are equal. You have to find the area of this equilateral triangle. Okay. Now, it's mentioned the perimeter is 180 centimeter. So if you know the perimeter of this triangle, you can use Heron's formula because S is perimeter upon 2. So perimeter is 180. Let us assume that each and every side is A. So A plus A plus A is 180. Then you get 3A is 180. So from that we calculate and we get A as 60. Now semi-perimeter is perimeter by 2. So it becomes 90 centimeter. Use Heron's formula and find the area of the triangle. So it is square root of S, S minus A, S minus A and S minus A. Generally we write here S minus B and S minus C, but B and C values are the same. It is throughout A because it is an equilateral triangle. So B becomes A and C also becomes A. Substitute the value. S is 90. So 90 minus A. But what is A here? 60. So again 90 minus 60, 90 minus 60. This is what you get when you solve it. Now root 30 into root 30. Square root of 30 into square root of 30 means 130 will come out. So I've taken 30 outside. Then 90 can also be expressed as 30 into 3. So this root 30 and this root 30 means another 30 comes out. So the answer is 900 root 3. 900 root 3 is the area of this equilateral triangle if the perimeter is 180 centimeter. So in this slide, you notice that we have used Heron's formula because the perimeter is known. We found out S and then we found out the area of the equilateral triangle. Okay, 900 root 3 centimeters. In this slide, I am deriving the area of an equilateral triangle by using Heron's formula. This is the Heron's formula. So S is 3a upon 2. S minus a is 3a upon 2 minus a. Same thing you're repeating here and here. Now 3a by 2, write it as it is. Solve this part. I want you to solve this in rough. 3a upon 2 minus a means you're taking out the LCM. So it becomes 3a minus 2a upon 2. So that brings it to a by 2. You know how to subtract when denominators are not the same. So here also you will get the same answer, a by 2. Here also you will get it as a by 2. Now this 3a by 2 can be written as 3 into a upon 2. So a upon 2, root a upon 2 into root a upon 2 means 1a upon 2 will come out. Take a book and write down this. Root a upon 2 into root a upon 2 means a upon 2. Similarly, square root of a upon 2 upon into square root of a upon 2 is another a upon 2. So totally you get a square upon 4. And this 3 is under the root sign. So you get it, you write it as root 3. So this is nothing but area of an equilateral triangle. We have calculated the area of an equilateral triangle by using Heron's formula. So area of an equilateral triangle is root 3 upon 4 sides. Alternate method. Now that we know what is the area of the equilateral triangle, we will find out the area of that triangle by using the formula directly. Now this is the area of the equilateral triangle, root 3 upon 4 side square. You know that each side is 60. We saw that in the previous slide. So root 3 upon 4 into 60 square, where you're using a as 60. So when you solve that, you get the area as 900 root 3 centimeters square. So what do you notice? In this question, we have found out the area of the triangle by using Heron's formula. Then we use the Heron's formula to also derive the area of an equilateral triangle. This is your homework. We have done a similar problem in this video lesson. Go through it and solve this question in assignment sheet or in your notebook. I want you to learn Heron's formula and see how to apply it in problems. Until then, goodbye and thank you.